Welcome to Ask and Learn.
All right, guys, we're doing problem 122 of chapter 5 of Chemistry Essential Science. So we're going to be looking at 3 acid-base reactions. So we're going to use data in Appendix C to calculate delta H for each of these reactions. So, let's do this. Remember Hess's law, delta H of reactants. Sorry, delta H of reaction is equal to delta H of products minus delta H of reactants. So delta H is equal to U minus 285.83 then you have NaO3, so minus 446.2 minus 469.6 minus 206.6. So minus 285.83 minus 446.2 minus negative 469.6 minus 206.6. This is a minus 55.83 kilojoules per mole. Well, next we're going to do this one. So delta H is equal to minus 285.83 minus 407.1 minus that's the NOH value minus 469.6 minus 167.2. Delta H is going to be equal to minus 285.83 minus 407.1 minus negative 469.6 minus 167.2. So that's going to be minus 56.13 kilojoules per mole. And now we're going to do that again here. So delta H is equal to minus 285.83 minus 240.1 minus 46.19 minus 469.6 minus 132.5. So our delta H for this is going to be five. So this is going to be a positive 29.8 kilojoules per mole. Oh, so now we know this, now delta H for each reaction. So they want us to write net ionic equation for the reaction of nitric acid and HCl. So remember, in acid-base equations, your net ionic is always H plus OH yields H2O. Now, for the next part, they want us to compare the delta H values for these two reactions and what can we conclude. So you see that the delta H for the HCl with NaOH is approximately minus 56 kilojoules per mole, and the delta H for nitric acid with NaOH is approximately 56 kilojoules per mole as well. So we can say that when a strong acid reacts with a strong base, the delta H for this reaction is approximately minus 56 kilojoules per mole. So in the third equation, NH4 plus is acting as an acid. Based on the value of delta H for reaction, do you think is a strong or weak acid? Explain. Yes. And if I had to and I would expect this to be to be a weak acid. So you can think of it this way. So we have when you're interacting a strong acid with a strong base, you're producing a delta H of minus 55 kilojoules per mole. But you can see in this reaction, the enthalpy is much smaller than for the first two reactions. So we can, based on this, so we can say that we were able to generally say before that when you add a strong acid with a strong base, this is going to have negative 56 point. You're going to get this value of minus 56 kilojoules per mole. However, in this case, you're reacting an acid with a base, but you're not getting that minus 56 kilojoules per mole. You're getting positive 29.98 kilojoules per mole. So since it's not producing that value, we can assume that this is a weak acid.